Hey, we're going to do math stoichiometry. Yes, practice sheet number 2, problem number 2. So here's the problem right here, and here's the steps that we're going to take in order to get through our stoichiometry question. So it says, when sodium iodide is mixed with chlorine gas, it produces sodium chloride and liquid iodine. What mass of sodium is produced when chlorine gas reacts with 0.29 grams of sodium iodide. So the first thing that we need to do is we need to come up with a skeleton equation. Okay, so we have to look at what we have, and we have sodium iodide. Now sodium iodide, there's no Roman numeral, so it's a type 1. The last one ends in "ide", so that means that it's not polyatomic. So we can look basically at what column it's in. Now sodium is a +1, okay, and iodine is a -1. Now how did we come up with that? Well, let's go to our packet, and if we go to our packet, we can see that sodium's in column 1A, which means it has a +1 charge. Iodine is in 7A, which means it has a -1. Or again, we can always go to our sheet here that tells us what it is. So we go to this sheet right here. Sodium is a +1 and iodine is a -1. So let's go back to our questions. Okay, so we have those right there. Since they already cancel each other out, we just have to write one of each one down. So we're going to start right off down here by putting sodium and then iodine. Now again, because this is close to that, we're going to change the font. Okay, I like changing the font just a little bit to make sure I can see. Let's see if that works. That works right there. So we're going to change the font, and that is going to be mixed with chlorine gas. Well, chlorine gas is just Cl, but what's the problem with chlorine gas? It's not just Cl. What is it? Well, it's Cl2 because chlorine gas is diatomic. If I go back to our periodic table, and again, we like to put this at the top, we have our elements that are diatomic, which are nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, plus hydrogen, which is over here. Okay, so we have the 6 that are here that make a 7, and our 7th one is hydrogen. So that is diatomic. So in order to put diatomic, we have to know that we have to put that 2 there. Our next thing is we're going to say that that's going to yield, okay, and it's going to produce what? Well, it's going to produce sodium chloride. Well, again, if I go over here, this ends in "ide", so it's just going to be a binary. There's no Roman numeral, so it's type 1. So this one is a +1, just like it was on the other side. And chlorine, and we'll double check chlorine real quick. We'll see what that is if I go to our packet. Chlorine is right here, which is in 7A or 17, which makes it a plus or a -1. Okay, so it's a -1 also. We'll double check right here on our sheet right here. Here it is right here. Okay, a -1. So let's go back to our question, and we know that that's a -1. They cancel each other out, so we just put one of each one down. So I go back over here, and we're going to put in our sodium and then our chlorine, one of each one. But it has liquid iodine left, so we're going to go with iodine. But as always, when there's an element by itself, we have to ask the question, is it diatomic? Okay, go back to our periodic table. We look over here. There's our 7 right there, right? There's our 7. So iodine is diatomic. So if we go back here, we have to make sure that we add a 2 to that. So now here is the unbalanced or skeleton equation. Now we have to balance it. So how are we going to balance it? So we're going to go ahead and write down all the elements that we have on each side. So we're going to write down sodium. We're going to write down iodine. I'm going to write down chlorine. That's what we have on this side. We have 3 capital letters, so 3 elements. So how many sodiums do we have? Well, I look at this and I see that, to be honest, there is just 1 sodium. So we're going to put a 1 right here. I look at the iodine, I see just 1, so we're going to flip it over and put a 1 there. And chlorine, I have 2. The subscript tells us that I have 2, so we're going to put that our 2 in there. Okay, so now we're going to go to the other side and put those same elements, Na, and then we're going to put iodine. And again, I could put chlorine. I mean, I have chlorine right here, okay, but I don't want to put that chlorine next because I want to keep them away opposite of each other. So we're going to put chlorine down there. So if I go ahead and put how many I have of each one, sodium I have 1. Iodine, my next one over here, iodine we have 2, and chlorine we have 1. So our sodium's all together, so we got to change our iodine and our chlorine. So let's go ahead and do the iodine first. Since I have 2 iodines on this side, I need to put a 2 right here. So we're going to put a 2 right there. That means now that I have 2 iodines on this side, so I'll get rid of this one. Okay, but since I changed the iodine to 2, since I put a 2 here, and I can only change the coefficients, I can't change the subscripts. Okay, I have 2 sodiums also, so we're going to put a 2 there. And we're going to cross that out. Now that affected my sodium, so now I have 1 sodium on this side. I need 2, so all I can do is put a 2 right there. So now I have 2 sodiums there, and we'll get rid of this. But I also have 2 chlorines. So I'm going to come over here and put a 2 right there, and then get rid of this. And now I look at it, I have 2, 2, 2, 2, 2, 2, all 2s. Okay, so what is my molar ratio? My molar ratio is going to be 2 to 1 to 2. So 2 to 1 to 2 to 1. So we're just going to put that over in here as 2 to 1 to 2 to 1. Okay, so that's my molar ratio. I'm going to make that bold and make it nice and red so I can see it a little bit later. I could put the 1s in there if I wanted to. Okay, don't have to, but I could. I'll do that just to make it easy for us to know because we're going to need that when we do our molar ratio in the center. So let's go ahead and start our stoichiometry. When we start our stoichiometry, which we're going to put in right here, okay, so our stoichiometry, basically we're going to start with the mass in the problem. So in this case, we're going to start with this right here of sodium iodine. So here's sodium iodine. So we're going to go ahead and start with that. So I have 0.29 grams of NaI. And again, I'm going to change the font here just because I think that it's better for us to see it. Okay. And again, what do we do next? We're going to put times, and a line. Okay. What are we going to put on bottom? Well, again, I like to put on bottom, so we're going to put this on bottom, and we're going to go back up. We need the molar mass. So the molar mass is in grams, so we're going to go ahead and put that on bottom. So we're going to put grams of NaI, NaI. That's going to be that, and again, we need to change this back. That's what happens when I keep changing the things. And what are we looking for? Well, in this case, after I put grams down here, I need to convert it to moles. And again, the reason I need to convert it to moles is because then I can use my molar ratio. So the molar mass always equals how many moles? It's going to equal 1 mole of NaI. So how do I figure out what goes here? So we're going to basically just underline this. So I have to get the molar mass of sodium iodine. So I'm just going to come down here for a second, and I'm going to put this formula we're going to put NaI, which means I have Na and I have I. So we have how many sodiums? 1, right? How many iodines? 1. Now that's just in this. I'm not saying that I have 2. I don't go by these numbers here. I go by just 1 because we're going to use these 2 later on. So we're going to multiply this by the atomic weight, which is 23, and that's going to equal 23. Well, I have iodine, which I'm going to multiply by its molar mass, which I believe is 127. Let's double check that. Go back to the here. Iodine, 127. Ooh, another good look at it, and that's going to equal 127. Okay. So we're going to go ahead and tally these up. So we'll put that down here, and so the molar mass is equal to these 2 added together. So we'll pull out the calculator. Okay. And we will go 23 plus 127 equals 150. So that's going to be 150 what? Well, it's 150 grams of NaI. So there's our molar mass. So now we know that it's that. So we're going to put 150 right here. And now we can go ahead and get rid of anything that I have on top and bottom. So we're going to get rid of this right here. And we're going to get rid of this right here. Now my next step, if I go back up to here, it says I need to use the molar ratio to convert from moles of one substance to moles of another. So I'll go back down over here, and I'm going to put my line. But what I'm going to have moles of right down here. So how many moles do I have of sodium iodide? I have 2. So on the bottom, I'm going to put down 2 moles, okay, of NaI, and on the top, we're changing that to the one that we're asking for. So what is the mass of sodium chloride? So sodium chloride is right here. So we're going to have 2 moles of sodium chloride. Now again, we'll underline that. But now I have to get it from moles of sodium chloride because I'm going to get rid of this right here, moles of sodium iodide. So we'll get rid of that. And again, because I have it on top and bottom, I can get rid of it. So once we get rid of it, we have it in moles of sodium chloride. But I don't want it in moles, I want it in mass. So how do we get from moles to mass? Well, we use molar mass. 1 mole equals the molar mass in grams. So we're going to go ahead and put our times here. On the bottom, we said we're going to put down, since I have moles up here of sodium chloride, I'm going to put 1 mole of sodium chloride. Let's just go ahead and get rid of all that stuff for right now. Okay, but on top, we have to put in our grams of sodium chloride. But we don't know what that is right now. So we have to figure that out. So we have to figure out what is the gram. So we're going to go ahead right down here, and we're going to put in our NaCl. Okay, and we're going to figure out what we have of each one. So I have sodium, which I have 1. That's going to be times 23, and so it will equal 23. Now where did I get that? I didn't have to go back. I got it from right here. The next one is chlorine. So I have Cl. I have 1 chlorine. We're going to multiply that by what? Well, if we go back to our periodic table, if you don't know what it is, I know what it is. It's 35. Right there it is. So right there it is. So we're going to go ahead and go back to our thing, and we're going to put 35 in there. Okay, so once we do that, we're going to go ahead and we can equal that up, and that will equal 35. I just need to add the 2 together. So again, I have 5 and 3 is 8. Okay, so the molar mass is 58 grams of NaCl. So now I can put this 58 right there because I just figured out the molar mass. So we're going to put 58 right there. Now, can I get rid of anything? Well, we're going to underline this first. And then we put our equal sign. Now, there again, on almost every stoichiometry problem we're going to do is going to have 3 steps. So 1, 2, 3. We can do them independently, but it makes sense if we just kind of link them all together. So I have moles of sodium chloride here and moles of sodium chloride down here. So I'm going to go ahead and get rid of that. So we'll strike that through on top, strike this through on bottom. The only thing left is grams of sodium chloride. So I know at the end I'm going to have grams of sodium chloride. Now, is that what the question was asking for? Let's go back to the question. What is the mass of sodium? Well, mass is grams, so that's correct. So I got rid of everything. So now all I have to do is the math to figure out what my answer is. Now, again, we're going to multiply by the top, divide by the bottom. If I have a 1, I don't have to do that. Matter of fact, I have a 2 here and a 2 there, so I could even get rid of those. Okay? And we'll do the math both ways to see what it works out. So let me just pull this calculator up just a little bit. So let's look at it. We have 0.29. We're going to divide that by 150. Let's multiply by 2, then divide by 2, and then multiply that by 58. That's going to equal 0.1121333. So it's 0.1121333 and repeating 3. Okay, so are we done? Well, we're not done because we have to make sure we're in the correct number of significant figures. So if we go back to the original problem, here it is right here. Here's our number. I have how many significant figures? Is it 3? 3? Can't do that. 3? Nope, it's not 3. It's only 2. Okay, so it's only 2 significant figures. So when we have 2 significant figures, we have to go down here and put 2. So we put there. Our 2 says we drop all that off. So we're going to get rid of all that. So our answer is going to be 0.11 grams of sodium chloride. Once we get that, we can go ahead and highlight it. And that should be our final answer. Hey, we're done. Hopefully it helped you out. Hey, as always, go Mohawks. Nelson out.